Hello and very good evening, everyone. How are you all? I hope you're doing well. My name is Akriti. So let's start with today's question. This is the question number 2275 of Leetcode. Largest combination with bitwise and greater than 0, right? So in this question, we are given a vector candidates where um, where in the candidates we have some positive integers and we have to calculate the bitwise and of every combination of number of candidate kind of subsequence things like. Okay, so basically we are given an array and we have to find some subsequence of that particular array, and we have to take the end of all the numbers in that subsequence, and we have to find the largest combination of candidates with a bitwise and greater than 0, right? So basically in the question you are given an array which is named as candidate. Okay, so now I have to find the subsequence of candidates and I have to calculate the end of all the element in the subsequence. Now if my end is greater than 0, or simply I can say if my end is non-zero, then that particular subsequence is eligible for your answer, and you have to calculate the longest subsequence among all the subsequence, and you have to return the length of that particular subsequence which is longest and whose end is greater than 0, or you can say non-zero, right? So basically this is our question. In the example here you can see these many numbers are here in my candidate vector. Now I will just calculate the subsequence of this array and I will get many subsequence. Now I have to check which subsequence is the largest one and which is giving my end non-zero, right? So in the answer you can see 16, 17, 62 and 24. This is the subsequence which is giving the longest subsequence, and the AND operation of all the element in this subsequence is giving a non-zero value, right? So we have to return the longest kind of length of longest subsequence. Okay, so what actually our goal is? Our goal is to find a subsequence such that after taking end of all the element of subsequence we will get a non-zero value, right? So this is our final goal. Now how to get a non-zero value in end, right? Because if I say if a particular if I say I have a number and you have to check whether this is a non-zero or not in binary representation, right? Suppose if I have a number like this in binary and I will tell you how to check if this number is a non-zero or a zero. So I will simply say, yeah, if any bit in the number is equal to 1, then I can say, yeah, this is a non-zero number. So basically even a 1 bit is sufficient for a number to make it non-zero, right? So we will just do this only. We will just find at least 1 bit which is non-zero in the combination or in the subsequence, and then I can say, yeah, this subsequence is eligible for a non-zero AND operation. So let's start with the example here. As this was the example 16, 17, 71, 62, 12 and 24 and 14 in my candidate vector. Now I will find the subsequence which is just giving a non-zero AND operation, non-zero value after taking the AND operation. So how I am going to find it now? So basically what I wanted to do, I just wanted to take the AND and I will have to check even if it is just a single bit equal to non-zero, then I'm okay. Yeah, this is possible. So let's consider this example. In this example, we are basically given two numbers and we are taking AND of these two numbers. Now how is this possible for us to have at least one non-zero bit in my answer, right, after taking AND? So suppose this is my answer. This is the result of the AND operation we got after taking AND of these two numbers, right? Now, if I'm getting, now what is my goal? My goal is to find the at least one non-zero bit in the AND, right? After taking AND, in the result, I should have at least one non-zero bit. So here you can see this is my result of the AND operation, and I am getting at least one non-zero digit, right? This is one. So how did I get this particular bit, and what was the requirement of getting a particular bit equal to 1 in the end? So here you see, if I talk about the first bit, which is the first bit from the right, of course. So here in the first number, this particular bit was 0 and the second number it was 1. But we got 0 as the answer, right? Because both digits were not 1, right? In the second bit you can see both were 1. That's why only we got 1 in my AND. So this is something we got from here. If you want a particular bit to be equal to 1 in your AND operation, then you must make sure that all the numbers involved in the AND operation should have that particular bit equal to 1, right? So this is something we need to understand before going further. Now let's talk about, I'm just going to solve this question like suppose we have maximum of 24 number of bits, because this is something I have concluded with the help of constraint given below. Here you can see my candidate, my candidate, like all the elements in the candidate will always be less than or equal to 10 to the power 7, which is almost around 24 bits or something, right? So maximum we can have 24 bits in any number of array, in any number which is there in array, right? So we will talk about only 24 bits, right? So here I have bits from marking from 0 to 24. Now I will just talk about each and every bit, and I will say, because I only need to make at least one bit non-zero in my end, right? So I'm not required to make more than one bit equal to non-zero. I'm just happy with one bit equal to non-zero, right? So I will just start traversing for each bit, and I will check what if my this particular bit is not zero in the end, and then I will count how many numbers are giving 1 for this particular bit. I will just involve all those numbers in my subsequence, and I will say, yeah, this is my subsequence. Now I will go to the next bit. I'll check. I'll say, yeah, this is the particular bit which I'm going to make non-zero in my AND. So I will check how many numbers are there which are having 1 at that particular bit, because only those number I can, include in my subsequence, right? So I will just count how many numbers are there which are having 1 at that particular bit. Then I will just include all those numbers in the subsequence, and I will calculate the length of the subsequence, and I will just calculate my answer with the help of that, right? So let's start here. Suppose, yeah, let's start from the rightmost bit. I'll say, yeah, this particular bit, this is the bit number 0. From right, I'm saying, yeah, this is the bit which I'm going to make 1 in my AND. So I say, yeah, this is the 1, and I don't care about the remaining bit. Either they are 1 or 0, I don't care about them. At least I have this bit equal to 1. So this is sufficient for my AND to be non-zero, right? So I'm saying, yeah, this particular bit is 1. Now, if I want that this particular bit is 1, then how many numbers I can include in my subsequence so that this bit remain 1, right? So let's start from the first number. This is a 16. In 16, the bit at the 0th position is equal to 0. So no, I cannot include 16 in my subsequence. Now I'll move to 17. I'll see, yeah, in my 17, the 0th bit is equal to 1. Then I can include 17 in my subsequence. So yeah, one number I have got. Now I will move to 71. I can say, yeah, this number also has 0th bit equal to 1, so I can include this in my subsequence. Now when you see the other numbers, nobody is having 1 at that index equal to nobody is having 1 at that index. So I'll say I cannot include any other number in my subsequence. So basically, if I will consider that my 0th bit is equal to 1, or I'll say my 0th bit must be equal to 1 in my AND, then I can have only two numbers in my subsequence, right? So basically the number of element in that particular subsequence is going to be equal to 2. So let me write it here. If I'll say this is 1, so the maximum number of element I can have in my subsequence is going to be 2, right? Now let's move to the next bit. Now let us say I'm not concerned about this particular bit. Now I'm concerned about the first bit. It was the 0th bit, and now I'm concerned about the first. Now I'm saying my first bit is definitely going to be 1. Now I don't care about the remaining bit, right? So if my first bit is going to be 1 in the AND operation, then I can say how many element can I include in my subsequence so that I will get 1 equal to end of all the numbers. So here you can say only the 71 and 14 is having the one bit equal to 1 in their number or in the binary representation. So here also total number of element is going to be 2. Okay, now let's say I'm talking about the second bit at the bit at the second index. Now I will check how many numbers are having the second bit equal to 1 in their binary representation. So here you can simply see 16, 17, 71, 62, 12, and 14. These many numbers are having 1 at the second position. So 1, 2, 3, 4, 5, and 6. These are the 6 numbers which are having. So let me just check. 16, 17, 62, 24. Okay, so these many numbers are having one in the binary representation, then I can say, yeah, I will get the answer from here. I guess the binary representation is some, kind of wrong. Then you are not concerned about the binary representation or the example. I'm just explaining you the logic. Once you get the logic, you can just write it by yourself, right? So here I'll count the number of ones which are there in the numbers. And so I'm sure that, yeah, I can include all these numbers in my subsequence and I'll get my answer. Now, if I say I want to make this particular bit in my AND equal to 1, then I will check how many numbers are eligible for getting into the subsequence. So I'll just count the numbers and I'll say, yeah. So after considering each and every bit, the bit which is giving you the maximum possible numbers or the maximum numbers in your subsequence, this is going to be your answer, right? So I'll just calculate it. So this was the logic behind the question. Now let's code it. So I hope you understand the logic which we are going to solve the question. Okay, so let's say and with a number of elements in my candidate vectors. Okay, now I have basically, if I want to find whether the ith bit in a number is set or not, what we actually do, suppose this is my number, right? So if I say, just tell me whether the first bit in the number is set or not. Set or not means to see if it is 0 or if it is 1, right? So if a bit is set, it simply means the number is 1 here, right? So I'm asking whether the 0th bit is set or not. So how can you just calculate it? I will simply say, just make a mask and in my mask just put 1 at that particular index you are concerned about or you want to find whether the bit is set or not, and take AND operation. So once you take the AND, you will get if it is if it comes out to be 0, then your bit is not set. If it comes out to be 1, then your bit is set. Now if I will say just calculate whether the first bit is set or not, then I will make a mask and I will put 0 corresponding to that particular, I'm sorry, I will put 1 corresponding to that particular bit and I will take AND of these two numbers. And once I take AND, if I'm getting a non-zero number or something, then I'm saying yes, this particular bit was set. Or if I'm getting 0, then I can say no, this was not set or this was unset, right? So this is the way of finding whether a bit is set or not. So simply I'll make a mask, which is initially I'm not sure what is. Let's make a answer which is going to store the maximum number of element possible in a subsequence. Now I will consider every bit starting from the last one. We had 24 bit rights according to the constraint. So I'm just running this loop for 24 bits. Now I'll say I have to shift my mask for that particular bit, right? So suppose if you want to check whether the bit is set or not at the ith bit, then you will just shift your mask to the ith bit and you will take the AND, right? So I'll say I have to left shift my 1 to the ith bit and then I'll take n. Okay. Now let's declare a count variable where I will be storing how many numbers were there in my subsequence or I can have in my subsequence. Now for each number in the candidate vector, candidates, I'll check if a number at the ith bit, if a bit at the ith position is set or not. If it is set, that yeah, this particular number is eligible for being in my subsequence, and if it is not set, then I cannot include that particular number in my subsequence, right? This was our algo. So I'll just check if after taking the end of my num with mask, if I'm getting a non-zero value, then I'm sure that there was 1 at that position and I can include that number in my subsequence. And after doing all this, I'll just update my answer as maximum of answer comma count. And in the end, I'll return my answer. Okay. So this is something what we have done here. Now let's check if it's working or not. So yeah, it's working fine. Okay, so it's working. So yeah, guys, this was the whole explanation and the solution of the question. Now, basically the main idea behind the question was you are only concerned about making one bit equal non-zero in my AND operation, right? So you were just running after that only. You want to make at least one bit equal non-zero. You are not concerned about all the bits, right? So for making a one bit equal non-zero, you just have to include all those elements which are having that particular bit equals that in their binary representation. So I have just included all the elements and I calculated how many elements I can have, and then I'll updated my answer, right? So this was the entire solution. Now, if there is something which you could not get or you have any doubt regarding the question, you can simply ask in comment box. Thank you so much for your patience. Have a good day.